Hi everyone, these are the notes for lesson 7.4. So we have some vocabulary to talk about first. The first one is a net. And so a net is when you take a three-dimensional figure and unfold it, what it would look like with all the sides laid out flat. So this rectangular prism unfolded could look like this. And we're going to use nets to help us find the surface area. So a polyhedron is just a three-dimensional shape. So the sides have to be polygons. A prism is a polyhedron where it has two bases, so two flat sides that are parallel to each other, so like this shape. And that differs from a pyramid because a pyramid only has one base and the other sides meet up in a point, and then all the sides are triangles. And then a sphere is a round solid figure that has a radius. So all those points that are on the surface are equal distance from the center. Just like a circle, the circle is equal distance from the center. So like I said, this lesson is based on surface area, and the surface area is the sum of all the faces or all the sides of the polyhedron. To find the surface area of pyramids, we're going to need to find the slant height, and I just wanted you to see how it differs from the regular height. So the regular height would be how tall the shape is, so it would come straight down from the vertex up here. So that would be a regular height. But the slant height is the height of the triangle on the side. So if we just looked at that triangle that's there, the height would be from the top perpendicular to the bottom. Okay, so if you kind of look at it that way, it has two heights, the regular height and then the slant height. And it's kind of cool because when we look at this, those heights together with part of the base is going to form a right triangle. So if we're missing one and we need it, we can use the Pythagorean theorem to solve and find what we're missing and what we need. So inside on page 1, I wrote out some steps for you to be able to find the surface area of each of the shapes. There was a typo, so go ahead and scratch that out. It's actually how to find volume, not surface area. So for these, we're going to start by drawing the net. Then we find the area of each side, and then we add them all up. The only one that doesn't work for is spheres. Spheres have a special formula. Since we can't really draw the net for it, it comes out weird. I can show you a picture of what one looks like. But if you think about a globe and how they represent that sometimes flat, like two-dimensional, that would be kind of what the surface area or the net would look like, with like little rounded triangles kind of. Anyways, let's start with our first polyhedron on page 2. And here we have a cylinder. So the cylinder is made up of two circles on either end, so those are the parallel bases. And then if we unfold that part in the middle, it would end up looking like a rectangle. So we have a big rectangle in the middle, and then it has two circles on either side. So let's fill in what we know. We know that the this part, which would actually be the height if you stood it on end, is 3. And then our radius of that circle is going to be 2. And then the circles on either side are the same, so we just have to really worry about 1. So to find the area of that circle, we would do pi r squared, which we learned about in 7.3. So last section. So the area of the circle is pi r squared. So that would be 2 squared times pi, or 4 pi. So the area of the rectangle part would be base times height. And we know that the height is 3, but we don't know what the base is. But if you think about it, if I wrapped it back up, this base would wrap around that circle. So the base, this part, is the same length as what the circle would be. So it's the circumference of the circle is the length of this base. So the base part would be equal to 2 pi r, which would be 4 pi. So the area of the rectangle would be 4 pi times 3, which is 12 pi. So once we find the area of the pieces, we just have to add those all together. So remember that we had 2 of those circles. So we have 2 times 4 pi, because 2 circles, plus the area of the rectangle part. So we'd have 8 pi plus 12 pi. So the surface area of the cylinder would be 20 pi inches squared. So sometimes we will leave them in terms of pi, and sometimes we'll change them to the decimals. You just have to be careful about what the directions say. You know, does it say use pi, use 3.14, or leave it in terms of pi? So for now, we're going to just leave it in terms of pi because, you know, I don't like decimals. Okay, so let's look at our rectangular prism we have here. So for all of the prisms, the part around the center that goes around is like a big rectangle. So if you're having trouble drawing the nets, that's where I would always start with your prisms, is draw a big rectangle and then see how many pieces you have to split that up. So we have this big part on the top, we have the skinnier part on the side, and then the bottom, and then another skinny part that matches this side. And then we have the rectangle that's on kind of the front here, and then another one that would be in the back. Okay, so from there we just have to fill in the numbers that are associated with those side lengths and find the area of each of those rectangles. So I know that this part, the height is 4, so that would correspond to this. It's a little too big. So if this part is 4, then this part here would be 4 too, because when they fold together, they would touch. So this is 4, so this is 4, and the same thing down here. If you notice in this rectangular prism, you have 2 of each size box that are going to be the same size. So you really just have to find one, and then we'll times it by 2 because it's the same. Okay, so our total height here going back would be like this big line here, which is 17. So that means all the way across, all of those are going to be 17. And the only other number we would need would be this piece, which is 10. Okay, so I'm going to write it out again, or say it again. We have 2 of each boxes that are congruent. So that one would be congruent to that other little side, and then we have 2 of the big ones and 2 of those skinny sides. So you only have to find the area of each one time and then just times it by 2 because there's 2 that are the same. Okay, so let's start with the yellow one first. So the area of the yellow box would be 4 times 10 since it's a rectangle. The area of the orange would be 10 times 17. And the area of the green would be 4 times 17. So remember that was just for one box, but we have 2 of each box. So when we do it, we have to times them by 2. So our total surface area would be 2 times 40 plus 2 times 170 plus 2 times 68. We would add all of those together to get the total surface area. So this is 80. So if we add those up, we get 556 meters squared. So sometimes I don't write it out like this. I often do it like this, where I just write the areas inside the boxes. As you can see, the first time I did it, I drew my net completely, well, not completely different, but a little bit different than what I just did now. As long as you're matching up the side numbers and have all the sides represented, then it doesn't really matter how you draw it. Okay, so let's take a look at our triangular or square pyramid that we have here. When we name pyramids, or prisms, we name them by the shape of the base. So since our base here is a square, this is a square pyramid. So just like the prisms, I always start by drawing it the same. So I always start with my base here. So I draw my square. And then I know that each side is a triangle that comes off the square. So I just draw my triangles. Obviously, mine don't look anything congruent. Sometimes they don't look like a real triangle either. But it doesn't matter. We're just using this to help us make sure we get all of our sides. So as we can see on our square, we have 3 and 3 for those lengths. But then we're going to need to know the height there. And they didn't tell us the height of the triangle. They gave us the actual height. So remember when we were talking about slant height? That's our actual height. We need the slant height, this one here on the side. So we're going to use that little right triangle that's in there to find what our slant height is. Okay, so if we look at that triangle, they gave us that the regular height of it was 5. Then we need to know how big it is down at the bottom. So if you see, the bottom part splits that side in half, so that would be 1.5. So this would be C when we plug into the Pythagorean theorem. And then we can find our slant height. So 5 squared plus 1.5 squared equals C squared. Okay, so go ahead and do the math for that to figure it out. When we square and add those together, we get 27.25 equals C squared. So I'm going to let you round it for this one. So C would be approximately 5.22. So that means the height of our triangle is 5.22. So let's find our area. So the area of a triangle is 1/2 base times height. So the base of that triangle is 3. 1/2 times 3 times the height we just found to be 5.22. So if we times those out, we get 7.83. But how many of those triangles do we have? Good, so we have to multiply that by 4 since we have 4 triangles. So that would be 31.32. So all we have left is that square in the middle, and the area of a square is base times height, so 3 times 3, which is 9. So to find our surface area, we would do 31.32 plus 9. So our surface area is approximately, since we rounded that number way back up there, 40.32 yards squared. Very good. Okay, so let's get to our cone. So the cone, when it unfolded, kind of looks funny too. You know you have that circle, that's the base. The part that goes around it actually unfolds to look, whoa, I'm making mine really big, to look like a triangle, but it's curved at the bottom where it touches the circle. So our radius for our circle is 20. And then the side of our triangle, or the slant height here, would be 50. So if we do our area of our circle, we get pi r squared, which is 20 squared pi, so 400 pi. If we want to find the area of this piece, we can use the triangle formula. So it'd be 1/2 base times height. We know the height is 50, but we don't know what the base is. But just like with a cylinder, this base is going to wrap around that circle. So the base would be equal to the circumference, or 2 pi r. So that'd be 2 times 40 pi, or sorry, 20 pi. So the whole circumference would be 40 pi. So our base is 40 pi. And then our height was 50. So half of 40 is 20. 20 times 50 is 1,000. So that would equal 1,000 pi. So our total surface area would equal 400 pi plus 1,000 pi. So 1,400 pi centimeters squared. Okay, so let's take a look at our sphere on page 4. So the formula for a sphere, no drawing the net on this one, you just have to memorize the formula. So 4 pi r squared. So we'd have 4 pi times 5 squared. So we'd get 100 pi feet squared. Okay, so you have 5 examples to try on your own. And then we will go over the answers in class tomorrow. So make sure you do those examples though. If you don't, you won't get full credit for your notes. So you have to finish those examples and we'll talk about the answers in class. For the last example on page 6, remember we got a triangle on either side and then those 3 rectangles. So it's just like the other prisms. Okay. Make sure you write down any questions you have. Werner out.